We are from Species 360, and I'm Caitlin Mucha, Senior Product Owner of our population management tools. And before we dive into Taxon Profiles, we want to give a little bit of background on who we are at Species 360. So we're a Minnesota-based global nonprofit, and our mission is to foster international collaboration to improve animal care and conservation. And we do that through our Zoological Information Management System, or ZIMS. And that's where our taxon profiles can be found. Uh-oh. Real time. Okay. And ZIMS is a comprehensive, the largest comprehensive database of wildlife in human care anywhere in the world. And it's powered by over 1,300 of our member zoos, aquariums, conservation organizations, government agencies around the globe in over 100 countries, as you can see here in our member map. And we've been around for the past 50 years. In that time, we've worked really hard to make ZIMS a comprehensive database for wildlife information. And as a result, we have millions of records in our system. As you can see here, we've got over 33,000 species represented, over 41 million individual animals, and that means there's millions of records on those individual animals, from medical information to parentage to weights to lengths. ZIMS is a gold mine of conservation data. And that's where Taxon Profiles comes in. We're working to build aggregated tools that help our members make decisions for animals in their care. And so I'm going to turn it over to Rachel to demo the tool.
Thanks, Caitlin. I'm Rachel Thompson. I'm the Senior Product Owner for ZIMS for Medical, and I'm just going to walk you through the Taxon Profiles. So what you see first is a search bar, and members can come here to search for, let's say, a leopard, and then what they'll see is a list of all of the species and subspecies that we have that have been in ZIMS institutions. You also see here some conservation details, and that information is pulled from a bilateral API integration that we have with the IUCN Red List of endangered species. So IUCN shares their conservation status information with us, and we in turn share information on animals in human care with them. That partnership can help the wildlife professionals that are doing population assessments drive policy and conservation action. So then when we come back here to the taxon profile, if I choose the Amur leopard from this list, then I can see all the global details that we have about this species. We see the demographics about males and females, unknown sex animals in human care, which continents they reside on, and then also we have a graph of the average weight based on the animal's age. So as a veterinarian, I can use this graph to estimate the weight of a patient that maybe is a little difficult to get onto a scale without anesthesia. Or I could use it to estimate or compare the weight of my patient compared to the global trend. So let's use an example of an animal that lives here in Minnesota. If I'm logged in as the Minnesota Zoo, I can see the global trend, but I can also overlay my patients onto this graph. So this is a female, and since male leopards are bigger than females, if we filter by sex, we can actually make that range a little more precise. So what you see is a female cat that has a pretty traditional growth trend line, but if we zoom in a few years ago, you'll see that she actually had a decline in her weight. So her caretakers noticed this, and they worked with their veterinary team and were able to diagnose a mild chronic inflammation in her gastrointestinal tract. So with medication and nutritional intervention, they were able to normalize her condition, and then you see her weights kind of come back into that normal expected range. So this is exactly the kind of thing that we want our members to be able to do with all of these millions of data points that we've been collecting for 50 years. Make meaningful reference data that they can use to optimize the animals in their care. This is all really kind of what it comes down to. If we can do early interventions and accelerate action, that might ultimately, with a species that's evolved to mask their disease, it could actually ultimately change the outcome and maybe save a life. So as Jeff Lynn said, we're here to make the world a better place, and we all think that data can improve how we care for these species, and the world's a better place with them thriving. So Laura is going to give us a little more insight into the tech.
Thank you, Rachel. I'm Laura Gaucher. I'm one of our lead engineers at Species 360. And I'll talk a little bit about how we built this. Like Rachel and Caitlin mentioned, we have millions of animal weight records in our primary database. That's a Microsoft SQL Server database. It's been faithfully storing our members' data for many, many years, so we have a lot of data in there. So the first thing we did was spin up an additional secondary database that holds copies of all of those weight records, but in a structure that makes this kind of analysis faster and more efficient. So we have a process that runs every 3 months on our database server. It copies all of those weight records over. But as each weight record is copied, we convert the actual weight value itself into kilograms. I don't know how well you can see, but this graph, the unit is in kilograms, so that's the number we really care about for this. Weights can be entered in any unit of measure, so we do that conversion at that step, so it's ready to go. We also calculate the animal's age on the date the weight was taken and store that directly in that secondary database. And we kick out some records that we don't want in there, like Caitlin was showing. So if we find any that are missing their unit of measure, or the weight was taken before the birth date of the animal or after the animal died, things like that, we don't include in that other database. And then the next step is we have a Spring Boot backend that connects to that database and pulls all of the weights that we have for whatever species was requested and runs the math on them to get these averages and standard deviations. We do some statistical outlier analysis there too, so that if somewhere along the line somebody entered a weight in kilograms that they meant to put in grams, that's not going to throw off the whole graph. And that all happens on the fly in the Java code in that Spring Boot backend, which is a little bit newer addition to our tech stack. We've been working on modernizing our technology the past couple of years, so that's been really exciting to work on. And then those calculated numbers get served up to our React front end, which is what we're looking at here, another newer part of our tech stack. And we use a really powerful front end data visualization library called HighCharts to actually make the graph. So we're big HighCharts fans. That's the final step to turn those raw numbers into this powerful and intuitive tool.
Thanks, Laura. So you guys can see why we're really excited about our Taxon Profile tool at Species 360. We're hopefully changing conservation, and we're using really cool tech to do it. So if you're interested in connecting with us, learning more, please join us in Saving Species. Check out these QR codes, and we're looking forward to connecting with you after this is over. Thanks so much.